distance, displacement, and average speed. And today we will revise the velocity. Today we will revise velocity. Okay. So basically, uh, so basically, there is speed and there is velocity. So speed is a scalar quantity, velocity is a vector quantity. Speed is a scalar quantity, velocity is a vector quantity. So when we talk about speed, so we do not talk about the direction. Speed of 5 meter per second. Speed of 5 meter per second. Here no direction is involved because this is a scalar quantity. Scalar quantity, for defining scalar quantity, there is no requirement of the direction. Now when you will define speed, so you will say 5 meter per second along east, 5 meter per second along west. Means if you will define velocity, so you should have a magnitude as well as the direction. 5 meter per second is magnitude, and along north, along south, this is the direction. Along x-axis, along y-axis, along z-axis, this is the direction.
Yeah.
Yeah. So okay, velocity is speed with direction. Basically, velocity is speed with direction. So talking about the speed, talking about the velocity. Sorry. So basically, for velocity, there is a requirement of the magnitude, and there is a requirement of direction. And speed, this velocity is which quantity? Scalar vector quantity. Velocity is a vector quantity. And to define the vector quantity, magnitude and direction is required. So magnitude is basically, take one example. Suppose example is 2 meter per second along
Yeah.
east. So the magnitude will be 2 meter per second. Magnitude means the numerical value. So 2 meter per second. And direction, east direction. So like speed is defined as the distance divided by time. Speed is defined as distance covered per unit time. In the same
Yeah.
way, velocity is defined as displacement covered per unit time. Velocity is the displacement covered per unit time. So velocity is the displacement covered per unit time. Okay. So here is the example again: east, west, north, south. If I am saying 5 meter per second towards north, so this is the north direction. So in this direction, there is a speed of 5 meter per second. So that will be the velocity. If direction is will be specified, then it will be a case of velocity. So 5 meter per second towards north is velocity, and 5 meter per second, 5 meter per second is the magnitude, and this magnitude is also speed. This magnitude is the speed basically. So this
Okay.
magnitude is speed because 5 meter per second is what? If someone is saying 5 meter per second, it means speed. No direction involved,
Yeah.
speed. So 5 meter per second is speed, or this is also magnitude, or you can say the numerical value of the velocity, numerical value of the magnitude of velocity, numerical value of magnitude of velocity,
Yeah.
magnitude of velocity. As speed, we have defined uniform speed and the average speed. We have defined
Yeah.
speed first, uniform speed, another is the average speed. But the velocity we will define with uniform velocity or non-uniform velocity. Uniform velocity or non-uniform velocity. So uniform velocity means the velocity which is not changing. Velocity not changing. Velocity not changing means the magnitude as well as the direction is not changing. Hmm?
Hmm.
Magnitude as well as the direction is not changing. Uniform speed, uniform velocity. Velocity is not changing means velocity is what? Magnitude and direction.
Yeah.
So if the velocity is constant means the magnitude is also constant and direction is also constant. Here you can say, take the example. This is example. In this example, you can see this person is moving along east with 10 meter per second. So 10 meter per second is the magnitude and east is the direction. And neither the speed is changing or neither the direction is changing. Hmm? So you can say
Hmm.
this is the case of the constant velocity.
Hmm.
This is the case of the constant or uniform velocity.
Yeah. Okay.
Now non-uniform velocity. Non-uniform velocity means non-uniform velocity means velocity is what? Basically, velocity is what? Speed
Yeah.
and direction. Speed plus direction is velocity. So to change the velocity, either speed should change or direction should change or both should change. If speed is changing, means the velocity is changing automatically. If direction is changing, then also you can say the velocity is changing. If the if both are changing, hmm,
Yeah.
if both are changing, then you can say that then also the velocity is changing. Hmm? If
Hmm.
both are changing.
Okay.
In this case, suppose this is one example. In this example, the person is moving from A to C. Now you can say during this motion, the velocity is changing. From here to here, the person is moving along east. Hmm? The
Yeah.
person is moving along east direction. Okay, with 10 meter per second. So from here to here, there is no change in velocity. From A to B, there is no change in velocity. But after B, after the point B, the person takes the turn towards south. So now the direction change, the direction of the person change. Hmm? Now this, what you will call this velocity? What you will call this velocity? 10 meter towards south. So direction change
Hmm.
means that in this example, velocity is changing. Now from this second example, in this example, the person is moving from A to B with 50 meter per second, from B to C 10 meter per second. And suppose this is the direction east direction. So this is the east direction. So from here to here, velocity is constant. From here to here, also the velocity is constant. But from A to
Yeah.
C, if we will take the point B, after the point B, the person has the speed of 10 meter per second from 50 to 10 meter per second. Here speed is changing, means the velocity is changing.
Okay.
Okay. So these are the examples of the non-uniform velocity. Non-uniform velocity means the velocity which is changing.
Hmm.
Now, non-uniform velocity can be defined either into two ways. Average non-uniform velocity or instantaneous non-uniform velocity. First, we will discuss what is instantaneous velocity.
Hmm.
Instantaneous velocity, the velocity. Suppose you are on a bike and you are on a bike and you are riding the bike and your bike is running at 50 kilometer per hour.
Yeah.
But but you have the accelerator of the bike. You will accelerate
Hmm.
the bike, so speed of the bike will increase.
Yeah.
Suppose you are here on the bike. You are here on the bike. I don't know what is
Hmm.
this, but assume this is a bike or something. So you are
Yeah.
moving with initial speed u. Now consider this position as t is equal to 0.
Hmm.
Hmm. Initial condition. Okay, t is equal to 0 means initial condition.
Oh.
Now you are moving. Suppose you have reached here, and here your velocity is uh, 40 kilometer per hour.
Mm.
If I am asking that, tell me the velocity at this point. At this point where time is equal to 30 minutes.
Yeah.
30 minutes. And, and total time taken in going from here to here is suppose 60 minutes.
Mm.
60 minutes you are taking. So if I am asking the velocity at t is equal to 30 minutes, exactly at t is equal to 30 minutes, so that velocity will be considered as the instantaneous velocity.
Mm.
Velocity at an instant of time is the instantaneous velocity. So
Okay.
velocity at instant velocity at an instant of time is known as the instantaneous velocity. And instant of time means we are talking about very small time, means very uh, small time period, we can say
Mm.
approximately equal to zero, you can say.
Okay.
So for a small time interval, for a small interval of time. So instantaneous velocity can be defined as instantaneous displacement divided by instantaneous time. Okay. So basically,
Mm.
this is calculated by the differentiation method that is not in your syllabus, or that is not the part of your syllabus. In higher, when you will go for the higher study, there you will study that. We will focus more on the average velocity. So now average velocity is, what is the average speed? Total distance divided by time. Total distance divided by total time. Now average velocity is total displacement divided by total time. Average velocity is total displacement divided by total time.
Mm. Mm.
Okay, now what I will do, I will take one or two numerical so that you should understand it more clearly. Suppose there is a question. Now take your copy and pen, and Rayyan, please, I am starting the focus mode. Please open your camera.
Yeah. Okay.
Okay, so this is the question. Question number one. This is the first question. In this question, a body is moving from, assume here at A there is a person or there is a mass m, or there is a body or person here. So at A, the person has started the motion. The person has
Mm.
moved from A to B and covered 50 meter. No, 5 meters, sorry. Hmm? 5 meter he
Yeah.
covered. Hmm? and after that finally reached at B. Now the person moved from B to again in this direction. See here, again in this direction, he is going in this direction again, and in this direction again he has covered a distance of 6.5. Are you
mm,
understanding? Now the person is moving on a same straight line. These are not two straight line. Basically, this straight line is this, like this. Hmm?
yeah, yeah,
Okay, so I can write like this. It is better. So after that, moves from B to C. This is the point C, and this distance is basically 6.5 meter. So what is happening here in this question? Person moving first from A to B, then B to C, and A to B distance is 5 meter, and B to C distance is 6.5 meter, and time is given. Time in moving from A to B, 5 seconds. Time in moving from B to C is 10 seconds.
mm,
So, can you solve the distance? Can you solve this question? You have to find, actually, you have to find the average velocity. You have to find the average velocity. Find average velocity.
okay.
Okay, I am solving this question. Next question you will solve. Okay, I am solving this
Oh,
question. So now average velocity they are asking. So average velocity is basically what? Average velocity is what? Average velocity is total displacement divided by total time. Hmm?
yeah,
Average velocity is total displacement, total displacement divided by total time. So total displacement. For calculating the displacement in one means if the body is moving in a straight line, what you will do, you will consider one direction positive, you will consider one direction negative. So I am considering this direction as positive direction. If the person will move in this direction, so displacement I will take positive. And if the person will move in this direction, then the displacement I will take negative. Understanding?
yeah,
Okay. Okay, fine. So total displacement will be what is the meaning of the displacement? What is the meaning of the displacement is the straight line distance between the initial and the final position. So initial position is this, and final
yeah,
position is this. Basically, this
mm,
distance will be the displacement. So what is this distance? Can you tell me this distance AC? Hmm?
one third,
Hmm?
1.5,
1.5.
5, mm,
Right. It will be 1.5.
mm,
Okay. It will be 1.5. But negative or positive?
positive,
No, negative.
oh, no,
See
okay,
why? Why? Person is moving in this direction. Person is moving in this direction. 5 meter in this direction. So this will be plus 5.
yeah,
Hmm? This will be plus 5. And person is moving in this direction. So this direction you have assumed negative. So you will take minus of 6.5.
mm, okay,
So, okay, so this distance means you have to consider that you have to consider direction also. Okay, this displacement finally the result you are getting in this direction. Okay, so in this way it is better to do. First write the total displacement. In this direction
Yeah.
the displacement is 5 plus 5, and in this direction the displacement will be minus 6.5. So it will be minus 1.5, and minus sign is indicating this direction. Minus 5
Okay.
is indicating this direction. So total time we know 5 plus 10, 15. So it will be minus 1.5 divided by 15. So what will be the answer? So the answer will be 1 by 10, 0.1 meter, minus 0.1 meter per second.
Hmm.
Unit of displacement is meter, and SI unit of time is second. So now we have this. If average velocity, I have the value of average velocity. I have average velocity as 0.1 meter per second. If I have
Yeah.
this. So this is the negative sign. So what this negative sign indicating? This negative sign is indicating, just a minute, if I take, hmm, this negative sign is indicating this direction, na? This direction.
Yeah.
Yeah. So negative sign is indicated this direction. So what? Just a minute. One more example I will give you, then it will be clear. What happened? Okay. Suppose, hmm, suppose in this question I am changing little bit. This direction, in this direction is mm, east, and this direction is west.
Hmm.
Okay, now it will be clear. So this direction you have taken positive, means you have taken east direction as positive,
Hmm.
and west direction you have taken negative. So you are getting this answer minus 0.1 meter per second average velocity. So what is the meaning of this?
Uh,
The meaning of this is velocity is 0.1 meter per second west, along west, along west. So this is the final answer. Now what I will do now? In this case, what I have done? In this case, what I have done? I have just taken that east direction as positive and west direction as negative. Okay. Now what I will do now? I will take this east direction as negative and west direction as positive. And with the help of this, I will again solve this question. So what do you say, Rayyan? Will the answer change or it will remain same?
will remain same.
Hmm. If the answer will remain same, means this concept is right. We can
Hmm.
do that. Otherwise, this concept will be wrong. Why? Because it is not mentioned that which direction is negative or which direction is positive. This direction I am taking by myself. Suppose I have taken this direction. In the exam, you have taken this direction. So if
Yeah.
this concept will be wrong means your answer will be wrong. And what is the answer we are getting? The average velocity we are getting 0.1 meter per second west, along west. Now,
Yeah.
so with this, I will again calculate the average velocity. So average velocity is equal to the total displacement divided by total time. Total displacement divided by total time. Now, A to B displacement, A to B displacement in this direction, A to B in this direction. This direction is the east direction. So east direction you have taken as negative. So you will take, it is total displacement divided by total time. What I told you how to calculate the displacement. This direction, see on the screen. Okay, see on your screen. Uh, from A to B, the person is going along east and east direction. This time you have taken negative. So it
Yeah.
will be -5. It will be -5. Now, after that, the person moved from B to C, and B to C is the best direction. Best direction you have taken positive.
Negative.
So it will be plus 6.5. And total time is again 5 plus 10, 15. Total time will remain same, na? 10 plus 5, 5 plus 10, 5 plus 10. So it will be come out to be 1.5 divided by 15. So again it will be come out 0.1 meter, and this will be plus 0.1 meter, you can say. The answer will be plus 0.1 meter per second. So average velocity you are getting plus 0.1 meter per second. And plus means in this along the west direction, na?
Yeah.
So what you
Yeah.
can write? You can write 0.1 meter along west direction. See the final answer, 0.1 meter along west, 0.1 meter along west. There is no change in the answer. Okay, if you will change the
Yeah.
sign with respect to direction. So you should take this, okay, always. Try to take this direction. This direction you should take positive, and this direction you should take with negative. Otherwise, it's your choice. Otherwise,
Mm.
it's your choice.
Yes. Okay.
So this is the one first type of question we have. Another type of question in case of average velocity. Next question. Suppose a person is moving in this direction. A distance of 10 meter. Okay. After that, hmm, hmm. Find the hmm, okay, so next question will be this. A person is moved from here to here. a displacement of 10 meter, and after that the person moved from here to here, a displacement of again 10 meter. Okay, this is point A, and this is point B. Change the distance as 4 meter, 3 meter. 10 meter moved in this direction, and from this is C point. From C point, the person is moved again to any other D point. Okay, so finally the person is here. So you have to find the average velocity. Find the average velocity of person in moving from A to D, A to D. Okay, so you have to find the average velocity. Okay, you have to find the only magnitude of average velocity. Magnitude of average velocity. Can you do this question? And one more thing. This distance, the distance from B to D, is given as this person first moved to 10 meter, na? First moved this person 10 meter in this direction. 10 meter. In returning, he covered a distance of 6 meter. Now find the average velocity. And one more thing is given. Total time is given as 2 hours. No. Take it as 10 minutes. Now try this question. Then I will try. Okay, Azan. Rayyan. Try this. Apply your mind. You have to remember the for average velocity, total displacement divided by total time. Somehow you have to calculate the total displacement. And this time, I'm just asking the magnitude, not the direction. Okay.
Hmm. Sir, speed at 1.3.
It will be 5 by 10. No, it will be 0.5. No, no, not 0.5. It will be oh, 5 by 600, and it will be 5 by 12. 1 by 12. So it will be okay. I am solving. So in this question, now, what you have to do in this question, what you have to do, you have to find the total displacement. To find the total
Sir,
displacement. Hmm?
sir, someone's calling me. Can you just give me 1 minute? Thank you. Okay, sir.
Okay. Now see, basically for displace, what is the average velocity? What is the average velocity? Average velocity is total displacement divided by total time. Average velocity is equal to total displacement divided by total time. We know that. Total displacement divided by total time. So somehow we have to calculate the displacement. Okay. So in this question, how we will calculate the displacement, you can see here. This will be the initial position. The person has started the motion from here, so this will be the initial position. And what is the final position? What is the final position? The person is moved from A to B, then B to C, then return from C to D. So basically, this will be the final position. This will be the final position. So what we will do? We will join these 2 points, initial and the final position, like this. So
Yeah.
basically, this will be the displacement. This will be the displacement, and this angle is 90 degree. So basically, it will become a triangle ABD. Triangle ABD. And what will be this distance? BD distance. Can you tell me the BD distance?
4.
Yeah, very good. 4. It will be 4. 4 meter. So now we can apply the Pythagoras theorem and we can find AD. So Pythagoras theorem, when you will apply it, will be AD square, AB square plus BD square. So AD square, AB square means 3 square. BD square means 4 square.
Hmm.
So AD square, it will be 9 plus 16. It will be 25. So AD square is equal to 25. So AD is equal to under root of 25. So you will get a value of 5. AD you will get 5. 5 meter.
Hmm. Yeah.
So this value you will get 5 meter. Means the total what total displacement you are getting? 5 meter?
Yeah.
Okay, now you can do this. 5 meter is the total displacement. What is the total time? 10 minutes. So you will
Hmm.
convert 10 minutes into seconds. 5 to the
Yeah.
10. So it will be 1 divided by 120 meter per second. Not meter per second. So this will be the answer. The answer.
Okay.
Okay, one question I am giving.
One.
This is the question. Find the average speed of number 1 minute hand, number 2 second hand, and hour hand of the clock.
Hmm.
Have you seen the clock?
Yeah.
We have to find the average speed of minute hand of the clock. Uh, You should know the formula. You will apply the same formula again. Minute hand means formula for the average speed is average speed. This time I am asking average speed. So for average speed, what is the formula? Total distance divided by total time. Total
Hmm.
distance divided by total time. So for the clock, suppose this is the clock and this is the mm, this is the hand of the clock. Hmm? This is the hand of the clock, and this is the minute hand. So, minute for calculating the average speed for the minute hand. Uh, minute hand.
Hmm.
Average speed will be the total distance covered by the minute hand divided by the total time in which the distance is covered. Now, can you tell me? And one more thing here. Uh, uh, hmm. Given that, one more thing is also given in this question.
Hmm.
Length of minute hand, length of hour end, length of second hand is given. So length of hour end is suppose 1 meter. Length of minute hand is equal to 2 meter, and length of second hand is 3 meter. This is given. Okay, so this is the case for the minute hand.
Hmm.
So I am solving for the minute hand. Rest, you will try to solve it. Okay, so total distance covered by the minute hand. What will be the total distance covered by the minute hand? Total length of the circle, total length of the perimeter of the clock. This is the clock.
Yeah. Yeah.
So it will be 2 pi r, na?
Yeah.
2 pi. And radius will be this length, no? Radius will be this length, will become radius. This is given as for the minute hand. This is 2 meters.
Hmm.
You can write 2 pi into r means you can write length
Hmm.
L. Okay, L of. So you can write 2 pi r, and instead of r you can put 2 pi r divided by. So what is the time taken to complete one rotation by the minute hand? 1 minute,
Yeah.
1 hour.
Hmm.
Minute hand will
Yeah.
complete one rotation, complete one circle in 1 hour, na? So it will
Yeah.
be like this. It will be like this: 1 minute, 2 minutes, 3 minutes, 4, 5 minutes, 6, 7, 8, 9, 10, 11. When it will be 16 minutes, na? It will become a 1 hour. Then after that, what will happen?
Sir, you're lagging.
So what time the minute hand will take to
1 hour.
complete? Okay, now it's fine.
Hmm. Yeah, it's fine now.
And just wait for 1 minute.
Hmm.
Hello. Now it's okay.
Yeah.
Okay. Now tell me. Just tell me. Uh, how much time did the second hand of a clock will take to complete one circle? If the clock is circular, we know.
1 hour.
Second hand. 1 second, 2 second, 3 second, 4 second.
1 minute.
1 minute. Okay, now
Hmm.
tell me how much time did the R end will take
Hmm.
to complete one rotation?
1 hour.
12 hours. See, this is the hour end, 1 hour, 2 hour. Here is
Uh,
12. 12, na? 12
yeah.
a.m. 1,
Mm,
1 a.m., 2 a.m., 3 a.m., 4. See this here. Okay. Now you can see. See, this is the hand of the clock. Okay.
yeah.
Our end is this. So 12 now this time is 12 a.m. 12 a.m. So after that what will happen? 1 a.m., 2 a.m., 3 a.m., 4 a.m.,
Mm,
5 a.m., 6 a.m. How many
mm,
hours? From
6.
here to here, 6 hours. 7 a.m., 8 a.m., 9 a.m. Okay?
Mm,
10
yeah, I
a.m.,
know.
11 a.m., 12 p.m.
Mm, okay.
Hour and 12 hours.
Mm,
Okay, so 2 pi r divided by total time taken by the minute hand will be 60 minutes.
mm,
Hmm?
yeah.
60 minutes, no?
Mm,
So 2 pi and the length of this is 2 meter
mm,
and
yeah.
60 minute means 60 into, you will convert this into seconds, so it will become 30 and again you will cancel this out, it will become again 30. So the answer will become pi divided by 900 meter per second.
Okay.
So Azan, Rayyan, what you should do? And the rest of the things I am giving you as homework, and I will discuss in the next class. I will also will solve that. Okay, you have to find
Mm,
the average speed of second hand of the clock and hour end of the clock. Second hand of the clock SW and hour end of the clock. This is also your HW. And now you have to take the screenshots of the question that we did today. Or I think it will be better so that I should provide you the notes, link of notes.
mm,
Hmm?
yeah.
Okay, so that we will do later. First, you should take the screenshot. From here, na? Today we have done,
Mm,
these are the new questions I have added today.
yeah. But,
Oh, just a minute, just a minute. No, it's fine. Take the screenshot.
okay. Yeah, I took.
Took, okay.